Alright, first of all, you should have grabbed the 3 pages of notes on your way in. Our first page is going to be approximately 115, and we're going to hand write this in. So this is not something that you're gluing in. Series shortcuts. This equation and this equation, and I'm talking about arithmetic or multiplication, division with geometric, are going to be given to you guys. You're going to have a formula chart that has all these equations on it, okay? You knowing which one to use and how to use it is what you're trying to do. Again, let me remind you, today and next day, that is it. That is it. This unit is very, very short. So let me give you the breakdown. The next time I see you, you're turning in homework. Okay, so next Tuesday you're turning in homework. And you're learning your last day of content with me. Tier. Thursday of next week, you have your quiz over those 3 days of content. Okay? And on that Thursday, for the rest of the period, it is a little bit of a free day where you have the option to make up work. You have the option to retake a test if you failed a test recently. Or you have the option to start on your project. Okay? If you're a senior, you're exempt. You have to do 0 parts of this project. Okay? And it's the performance task. And the following Monday, okay, the following Monday is going to be a test day. And then we're going to allow you to retest that Wednesday. Okay? Because that Thursday and Friday of that second to the last week of school, that's it. That's the last day for seniors. And they close out, and then they have the senior privilege week. For this unit, you have 2 homework assignments. You have 1 quiz, and then you have the test. Okay? So this homework assignment that you're going to turn in next time I see you, after that I will assign a web assign. Okay, so if you don't have a web assign, make sure that you do print that off. You get those papers beforehand. And then, again, your quiz will be next Thursday. And if the test is not Monday, it might be pushed back to Wednesday. Okay? On that second to the last week of school. Guys, as you're noticing that this unit is not that big at all, we are allowing and giving you the opportunity and time to actually get a handle on your performance task. Okay? The performance task is actually pretty cool. I like it. I like it a lot. It's been a performance task that has been around for a long, long time. I will explain more in detail what it's about here, because there's a teacher that's going to come by here in just a minute and hand me off a bag. Okay? These are some companies that people drew. You'll get into groups. It's not a group project, but you'll understand, and I'll explain it all whenever they get here. But I just want to give you a heads up of what we're going to cover today. So those 3 pages of notes talk about the performance task. And if we have time, we can do some of the homework problems. Okay? Alright, so make sure that you do have the calculator out, because today is a little bit of calculator as well. But it is learning how to do it by hand. Because will you have a calculator and a non-calculator section on the test? The answer is yes. Okay, so here we go. Let me sign in real quick so that I can show you what I'm talking about when we get to the calculator. Okay. Alright, so let's go ahead and begin. So, what we're going to do today is look at series. And if you remember from yesterday, series is not just the list, it's adding that list. Okay? So, looking at this, you could put this in your calculator, you could do this by hand, or if you know which equation to do, you could get the answer quickly by making sure that you understand what the equation is. Now guys, you have to learn these equations because they're not all going to be this simple. These are pretty easy just as an introductory. Okay. Say again? Okay. So as far as adding these, let's look at what we have. We have 1, 3, 9, 27, so on and so forth. Guys, do you see a pattern as we jump? Times 3, yeah. Okay. You said it. So if it's times 3, we know it's going to be geometric. This is your progression through these problems, okay? So we know we're going to look for a common ratio, which in this case is 3. It's tripling each time. Okay. So now that we know R, we need to know N. And we also need to know A sub 1. Okay? Again, we know R, so we could put it like 1 minus 3 to the power of N over 1 minus 3. Now I just need to find out what is A sub 1 and N. What do y'all think A sub 1 is? 1. A sub 1 is the very first term. There it is. What is N? 7. There's 7 terms. This will be a non-calculator. So the sum or the series or the addition of all the terms of the first 7 will equal if I just did this. I don't have to do this all by hand. Okay? Yes, this will be something of the level of difficulty, thank you, of what you see on the test. 3 raised to the power of 7. Okay? And let's do this real quick. 1, 2, 3, 4, 5, 6, 7. We know this is 9. We know this is 9. We know this is 9. And there's a leftover 3. So on the test, quiz, whatnot, you would say this is 81. We know it's going to multiply by 9 still. So we'd get 729, which we still have to multiply by 3. This would be expected 2, 6, 8, and then you have 21. 2187 would be the infinite, not infinite, but the series or the sum of this first one. Did I do that right? I might have added incorrectly. 81 times 9 is 729, and then multiplied by 3, right? Oh, this is just for this piece right here. Okay? So the equation says we're going to say 1 minus this 2187. That means that this becomes a negative 2186 that we're going to end up multiplying by 1 and dividing by what? Negative 2. So if we divide a negative 2186 divided by a negative 2, the negatives cancel out. And yes, we're going to go back a little bit to 3rd grade. And we're just going to do long division. 1, remainder of 0, so on and so forth. This would be 0. Bring down the 8. Actually, that would be 18. So that you get 9, 18, just long division, guys. And 1093 is your sum. 1093 is the sum of all those terms done by hand. I promise you, you're going to have to know how to use these equations because you're going to have some that look like this. And you do not want to fill in the blank. That is a nightmare, especially when you're trying to do it by hand. Okay, so let's see how to develop to use the equations. First of all, what's the pattern? The jumps. Are they multiplication or are they addition? Addition. So we're going to use this one right here. What's the jump by? 9. See, the only thing that this number told us was that it's going to be the common difference, so I'm going to use arithmetic. That's all we need 9 for. That's it. Okay? For now, that's all we need 9 for. Now, the equation says n over 2 times a sub 1 plus a sub n. You tell me, what is a sub 1? The first term. We're going to say 4. What is a sub n? So if this is the first term, what do you think this means? It's the last term. So the last term is 139. You with me? Because that's the amount. This is the amount of the last term. How many terms are there? That's this number right here. You with me? So we need to find a way to get in. And there are only 2 equations that we're requiring you to memorize in this whole unit. And they are this one right, these right here. If it's arithmetic, that's the equation you need to have memorized. If it's geometric, this is the equation that you end up having memorized. Okay? We know we're going to use this one because it's arithmetic. Now watch carefully. Okay, this is the extension of how difficult it gets. I need to solve for n in order to plug that here so that I can get my answer and be done with it. Okay? So I'm going to use this equation right here, and for a sub n, I'm going to put 139 because that's the last term. A sub 1, I'm going to put 4. I know my common difference jump is 9, and then it's going to be n minus 1. Now I just have to do basic algebra to solve for n, and now that will give me that value right there. Help me out. Let's solve for n. Well, first of all, what should I put for d? 9. Here we go. So I'm going to move the 4 over. You with me? So if I move the 4 over, what's 139 minus 4? 135. What's the next step to solve for n? Divide by 9. So 135 divided by 9, it's going to be 1, there's 9, remainder of 4. So it's 15. And then what am I going to do? Add 1 and I get 16. All that work just to know that this is 16 here, that when I divide it by 2, it's like saying 8 times whatever this number is here. You with me? So 139 plus 4 is what? 143. And it's multiplied by 8. And you get 24, 32, 34, 1144 is your answer. Now, if you guys want to follow on Google Classroom, please do so. There's a lot of stuff that you can kind of look ahead. Some of you are getting this, but if you want to look ahead and if you have a question about what the next problem is, talk about, I think you can anticipate your questions a little bit earlier and stuff. Questions right now? Yeah. All right. So as soon as Judd gets back, what's going to happen is we're going to pick teams, or basically business partners and whatnot. You'll see in just a bit. Businesses. Whenever he comes back. So for now, are there any questions with number 2? Okay. So let's go to number 3. Number 3, it's saying that this right here is your function. It's the machine, if you will. And I want you to plug in the first one for n, which if you did, you would get 1 minus 1 is 0, you'd get 5. If I plugged in 2, you'd get 13. If I plugged in 3, you start seeing the pattern, 21. All the way to the last one, whatever it is, which is plugging in 12, you'd get 88, which is what, 93? And we want to know the sum of all that, just like that. Okay? This is the same thing. You're going to, first of all, ask yourself, which one of these is it that we're going to be using? What do y'all think it is? It's arithmetic, because they're jumping by addition. So we're going to use this equation again without a calculator. We should be able to identify this, of how to use this equation up here. And can someone tell me what we're going to put in for this n? Don't be shy. What is it? It's 12. Okay? Because there are 12 of them. Okay? 12 total pieces. What is a sub 1 going to be? 5. And then what is a sub n going to be over here? 93. So we will say 5 plus 93, there is a total of 12, and we're going to divide it by 2. You'll see that? So if you want to, mental math, we actually do this in number sense in our head without showing any work. You'd say 93 plus 5 is 98, divided by 2 is 49, and 49 times 12, you can do it without showing any work. So 49 times 12, you're envisioning this, but they're not writing it. You can write it, and then just multiply it out. You have the 18, you with me? So 18, 17, the next one's 8. I'll just show you, I don't want to confuse you. So 18, carry the 1, 8, 9, then 9 and 4. So you have 8, 18, carry the 1, you get 5. Okay, so 588 is what all of this would add up to for this series right here. Are we good? Okay. Again, remember, I do have that exemption for bonus or for homework. If you can answer the questions that I have, that question that I have at the end of today's lesson. All right, this one, geometric or arithmetic? Geometric, because of the fact that it has a common ratio and it's multiplying each jump. Okay, so we're going to have to use a different equation. We're going to use this one right here. And again, we're only working with this that's going to be provided to us without a calculator on the test and quiz. Okay, so now that Judd's back, I'm going to explain the performance task. If you want, please go on Google Classroom, and you'll see the post that I recently put on Google Classroom in regards to what is it that you're going to be held accountable, when are due dates and all that good stuff when it comes to the performance task. And that's not it. I don't even have a classroom open. All right. We'll go to 8. And here it is right here. So this one that says spring performance task. Okay. So I'm going to explain it, and I'm going to tell you all the pieces. I'm going to tell you when your first due date is. And again, seniors, just relax because you are exempt totally from this.
Why'd you have to wait for me? I haven't seen it.
Oh, I'm sorry. Yes. All right, here we go. Advertising agency project, pre-calculus second semester performance task. This is your final exam grade. There are 3 stages to this, but it all accounts for your final exam grade. You are a graphic designer for an advertising agency. A local business has come to you to design a new logo for their company. They want the logo to be recognizably or a recognizable shape that represents the product or the service that they provide. So if you see Nike, you're not going to replicate Nike's logo. You're going to create one that you think represents Nike. So they want the logo to be recognizable. The company is also looking at other advertising agencies for their design and will expect you and your competitors to present your design to them. Okay, listen. So your table will pick a company business that has approached you to design their logo. This will be the company, so on and so forth. Now, for today, what I want you to know is you're going to be putting groups here in just a bit. The groups are going to consist of 3 to 5 people. That doesn't mean one person's going to do all the work, because that's not how this project works, okay? That just means you 3, maybe up to 5 people, are going to have the same business, okay? So if you all pick, let's say, Walmart, then that means every single one of you are going to compete against each other for the best logo. But anyway, due to the company for mid-project approval. Okay, so on Monday, May 13th, for B-Day, your basic design, hand-drawn, not on computer, but hand-drawn on graph paper, needs to be turned in. Okay, so B-Day on the 13th, hand-drawn, you're going to turn in your design. I'm going to show you an example of one here in just a bit. Each person in your group will create their original design. Now check this out. Not replicating one that is already used, not on Desmos, not on the internet, or created by another person. You will be competing against your group members for the best logo created. And there are bonus points for the best logo created. Okay? So the requirements. Pre-AP has 45 parts. You have a minimum of 20. Okay? Pre-AP has to do parametric, function, and polar. All you have to do is function and parametric. But guys, there's so many things of a checklist that you have to cross-reference and make sure that you're doing. Just please don't blow this off, because there's a lot involved. For instance, 7 different shapes: line, parabola, the exponential function, trigonometric, logarithmic, all different types of shapes. At least 7 you must have. At least 2 different conic sections, and at least 1 trig function must be used. You need to have a minimum of 4 different shapes in regards to graphing the function in function mode, and 3 different shapes in parametric mode. The drawing must be recognizable and reflects that company, whatever it is. Okay? Draw function shapes in one color and parametrics in the other. So I should see nothing but 2 colors for y'all's project. Obviously, there'd be 3 colors for pre-AP. Each shape on your graph should be numbered, and you should provide a key to match the graph that gives the shape and the type for each piece. We're going to keep the picture simple, and I'm going to show you an example here in just a bit. Guys, draw the X and Y axis where it fits best, and then don't rotate shapes. All these different rotations, people are making it way more difficult than what it needs to be. Don't draw small details. The smaller details you draw, the harder and more difficult it's going to be to find the domains and all kinds of things for those functions. Draw shapes so that they start and end on crosshairs. So on a graph paper, right, you want to end and start on crosshairs. For instance, here's an example. So if you have your graph, you want it to end on a crosshair. You don't want it to start here in the middle and then end here in the middle. Okay, you want it to start where there's four corners, and whatever it does, it's going to meet at another four corners. Okay, that's what it means by those crosshairs. 5 extra bonus points will be awarded to any design that correctly uses more than 40 parts. So if you want to do 40 and get 5 bonus points, and you correctly use them, there's already 5. 5 bonus points. And includes at least 10 different, not 7, but 10 different, including a polar function. So if you want to do to the level, basically, of that pre-AP, we already give you 5 bonus points automatically. No more than 4 of one shape. So don't give me 10 circles and expect me to give you 10 credit for shapes. You're only going to get 4 at max. Okay? On presentation day, the CEO, which is me, the board of directors, which is you, will choose by voting the winning logo from each group. So the groups that you're going to pick here in just a bit, you're going to compete against these groups. Okay? And the winner will receive 5 bonus points. So there's 10 bonus points. Now, I can't scare you enough with this next thing. Please do not look on Desmos and copy something. You can look on Desmos and get ideas. You can look online, you can get ideas. But if you copy straight up, you're going to get a 0. And to help catch people who are wanting just to copy, we're adding bonus points to the following. Okay? So as people are coming up to present, if you can find their presentation online, that means they stole it, you will get bonus points, and they just got a 0. And if you find that 5 different people stole designs, you will get 5 different bonus point opportunities, and those 5 people, you'll remain anonymous, those 5 people will get 0s. Please, I cannot reiterate that enough. Do not copy something that is online. You do it yourself. Cool? I hope that motivates you the right way. Alright, questions? Alright, so let me pause the video. We're going to pick companies. Alright, so again, let me remind you, for the first thing, and you can write this down, take a picture, whatever you need, these dates will not change. Let me remind you this, let me warn you a little bit. Some of you, on some of the projects you did before, procrastinated some on certain parts. Because this is the final exam, we don't have time for that procrastination. If something is late and you needed to turn it in by a certain date, however many points you were supposed to earn with that, we're not giving you the opportunity to re-earn that back at all. So please understand. These dates are very, very tough as far as they're not going to be flexible at all. So May 13th, all I need is a drawing from you. And now look, this is an example. So, whoops. So this is sideways, but there's an example right here where all the functions are going to be here, and on a different one are look, line, 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 parabola, parabola, sine, sine, absolute value, line, ellipse, circle, hyperbola, so on and so forth. And you're going to turn it in on a graph sheet of paper. Notice this. And this is your own design, whatever you come up with. Okay? For the second part, you're going to actually give me the equations for all of these different pieces. Okay? You're going to tell me, is it in parametric or is it in regular function notation? And you're going to give me the equations, and you could use Desmos to build it. You know what I mean? As far as to build the picture that you drew by hand. You all with me? So please, don't use Desmos until after you've done the picture. I have to approve the picture first. Because if the picture is too difficult or it's wrong, I'm going to let you know before you start going to all these functions. Okay? Because otherwise you could make this a very difficult project if you're not careful with your drawing. Okay? Any questions? Okay, so let's keep going then with our notes. Number 2. Actually, what were we on? 4. Alright, so we have a geometric series. We know that r is equal to 1.4. We know that a sub 1 is 20. So we have 1.4 raised to the power of n. Because there are 6 terms that we are looking at, that's going to be n. And it's 1 minus 1.4. Now, the setup on this, I don't expect you to do 1.4 to the power of 6 without a calculator. But I do expect you to be able to write this and transform it to this equation on the test if needed. Okay, just so that you know the relation between doing this in this notation versus doing it using the geometric series formula that we will provide to you. Okay, and yes, you should get an answer like 326.4768 when you were to solve this out. So, series of 6 terms, you would just say right there, 326.4768. Questions so far? No, this one won't be by hand. Not with the 1.4 to the power 6. That's kind of crazy. We don't use these 84s, so I don't expect you to look at these right here. Like, this is not important, but we will use the inspire. Okay, so let me show you something as far as how you can do this by hand several different ways. Okay, here we go. First of all, if I wanted to find the sum of the sequence of the following, I'm trying to look at from the first one all the way to the 5th one. I have not shown you this right now that I'm about to show you, so please follow me. And we're going to list all the terms. Okay? Our equation is this right here. And I'm going to list the first all the way through the 5th term all in a sequence. Here we go. So, go to the calculator, and I want you to press SEQ. And our equation, is it not logged in? It should be logged in. Let me try that one more time. So, let me capture my calculator. And I think it is delayed or glitched. Hold on, let me try one more thing. Alright, so let me try capturing. There we go. Okay. Here we go. So I'm going to list out 8n plus 5 right here on my calculator. Here we go. SEQ. The equation is 8n plus 5. What's my variable? N. Comma. What's the ones that I'm wanting to show? The first, comma, all the way to the 5th. And press enter, and there you see it. Now, if I wanted to add all those, which is what I'm trying to do, you can press SUM for sum. You can go up there and press enter to grab and copy, and it will actually add all of those things together and give you 145. So that's one way of doing it. Okay? Yes, you can put it in as far as, look at this button right here, next to the book. You can put it in as a summation, which is right there. And you'll say, from the first term all the way to the 5th term, I want to add those that belong to the equation known as 8n plus 5. It will do all that for you of what we just did by hand. Okay? But knowing both is a strength, because sometimes we will ask you to list out the thing, and if you know how to use it in the calculator, why not? It'll help you out as far as the answer goes. Alright, so now we're going to start getting into those questions that I was trying to tell you are the big key questions that I'm going to ask you here at the end. Okay? And yes, guys, this is just plugging it into the calculator. There's not that much to it. Let's say we do C. It would just be the same thing, but this time it would be to the 100th term. So you could even go up there, copy that by pressing enter, and then just go up to where it says 5 and just change it to 100 terms. So now it's going to add up the first 100 terms. And you get what you see in your notes of 40,900. Are there any questions? Because I know this is a little bit just plugging and chugging, but are there any questions in regards to that? Okay? Alright, so let's look at this following slide that has the questions dealing with all of these things. So there are my answers. And this right here in our notes says, which of those that we just saw are geometric? And what do they have in common? And what do they have different? Can y'all tell me which one of these are geometric? This is I'm now into that question, okay? Where we're going to build up to that big question. Which ones are geometric? Just say it out loud. Which numbers are geometric? 3, 4, and 5. How do you know? You said multiplying, and you're right. You're right. And the common ratio, even more right, but further because of the exponent. Okay? So the exponent is the big key. It's kind of showing you it's the power of something known as the common ratio. That's huge. Okay? So you could say they are geometric and their sums are increasing. However, 4 and 5 have a limit to their sums. Okay? So number 3, 4, and 5, they're all geometric. Okay? And are increasing. Sums are increasing. Okay, so let's go back. You see their sums are increasing. See, they're getting bigger and bigger and bigger. But the difference is it says 4 and 5 have a limit to their sum. Notice this, they stop. They kind of stop. They don't keep going. Whereas 3 just keeps going on forever. Do y'all see that? So if this one goes on forever, we're saying it's diverging or diverges. Okay? This means it's getting out of control. Where these over here, they approach a limit, otherwise a horizontal asymptote, we call it converging. Okay? So converging. What does converging mean to you right now? Like, not just with math, but have you ever heard the word converging? So when you converge on something, you all kind of like group onto it, right? You all kind of gravitate to something. So converging in this case, let me give you an example of what converging means. So 1, 2, 3, 4, 5. You tell me, the function that I just drew, do you think it converges or diverges? It converges. What does it converge to? Someone said it. Y equals 1. It converges to y equals 1. Y'all with me? How about this one? Does it converge or diverge? This one, I maybe didn't draw it clear enough. It would converge. You with me? This one converges, it's best for you to see the pictures, to y equals what? 5. Do you see how I'm doing this? So it's basically, it's zeroing out, or it's like it's called a carrying capacity. It has a limit to it. It doesn't go up, it doesn't go down, it kind of goes, like if something was kind of like, it's like an equilibrium, if you will. You see what I'm saying? As far as if you have a spring and you know the spring is like oscillating up and down. So let's say that we have a spring. And the spring is doing something like this. Oh, come on. It's not going to let me. But it's kind of going wang, 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 whatever. There's a point of equilibrium of where it will stop. It won't go below or above anymore. That's kind of what this one is doing. Okay? And what would you say that one's doing? This one's diverging. Even though it looks like it's converging on a straight line going to the left, the way we read if it's converging or diverging is that we approach infinity. As x approaches infinity, in other words, as you look to the right, what is the graph doing? Is it taking a nosedive and just falling? Is it going up out of control? Or is it kind of like leveling out? And there's a good word for converging. Leveling out to a horizontal asymptote. Go with me? Yes, it has to be with a limit to be converging. Okay? Alright, so let's go back now to where we were at. Number 8. It says, if we look at the limit as n approaches infinity, which of the geometric series would converge, have a limit that exists, and which one would diverge, have a limit that does not exist? Okay, so number 4 and 5 converge. Okay, let me go back. 4 and 5 converge because what? Why do you think these converge? If you didn't look at these numbers, if you didn't know what those numbers were, and you were strictly looking at the equation, because it's less than 1. Because r is less than 1, in other words, like a vertical compression, all these numbers are getting smaller and smaller each time. You with me? So, look at this. 3 is divided by 3 to get 1. Divided by 3 to get 1/3. 1/9. And it just keeps going, and it gets closer and closer to what number? 0. So all of these numbers are getting closer to 0. Look at this one. Is this one getting closer to 0, yes or no? Yes, it will continue to get closer and closer and closer and closer to 0. Okay? But number 3 diverges. And why does number 3 diverge, guys? Because r is bigger than 1. It's out of control. It's a vertical stretch. It's going to go without bound. Okay? Alright. So, what property of geometric series can be used to determine convergence and divergence? If r is less than 1, the series will converge. If r is greater than 1, the series will diverge. Do you think the series in 6 converges or diverges? This is my question. Okay, so I'm going to ask you one time. Pay close attention. I'm asking you right now, and I want substantial proof, not just a guess and you give me credit. No, I want you to know and say what's the justification as far as why it converges. Okay? So I'm looking at the series for number 6. First of all, is this list the series? Nope. This list is the what? The sequence. This is the sequence. So the series would be adding all these numbers. You with me? So let me ask you. Is the sequence converging? What am I asking when I say, is the sequence converging? Is it slowing down, or are these terms approaching some number? Whether it's 1, whether it's 10, whether they're all approaching like 0? You know what I'm saying? Let me ask you. Is the sequence converging, yes or no? It is. The sequence is converging. The sequence is converging to what number? 0. Okay? So the sequence converges to 0. You with me? Over here, these converge to 0. Why? Because r was what? Less than 1. You with me? Is there an r here? So you tell me, is the series, in other words, these numbers, the summation, is that converging? No, what is it doing? It's diverging. So the numbers are honing in. Look at this one over here. This one right here. These numbers were converging to what? To 0. What were the series? What was the series of this? Was it converging? Yes, this was converging. The series was converging to 4.5-ish. You see what I'm saying? It's like converging to a certain number because this is converging to 0. We said this is converging to 0. And now you tell me with justification. Why is this one not converging? Why is it diverging? Speak up.
Because of the fraction 1 over n.
What about it?
Like each time you change the value of 1, it's affecting the series. Like each time you're increasing by half, and then like all of a sudden you increase by 1/4.
All of a sudden, what happened? All of a sudden, you increased by what?
1/4. Like each time you're like adding the more.
But we were doing that here. He's saying you add 1/2, then you add 1/4, then you add 1/8, then you add 1/16. We were doing that here too. You're on the right. You started right on, but you got to finish it.
It's going to vary what the limit's set to.
How? What do you mean?
So if n is 1, it's just going to be 1. If n is 2, the summation is going to be 1.5. And the longer it goes, because you're just going to keep halving it, it's going to be increasing by smaller and smaller. So it's never going to end.
You're getting closer. You're both kind of on it right now. Okay? The way he started and the way he's ending right now, and I don't mind a warning if you can bring it all together. What's the explanation that says that the series will diverge when the sequence converges? Not because it's parabolic. What did you say, Walter?
It'll never equal 0 because n will never be 0. And even then it would be undefined. Like it's always going to be equal to something.
Okay, here's what I'll say. Because you're pulling away from it now, okay? Let me give you a graph. I'll help you out. What is this a graph of? What is that a graph of? Exponential decay. What is this a graph of? One over n. So this one is e to the negative x, and the blue one is 1 over n. This one, the numbers get smaller and smaller and smaller and smaller. And the addition of those numbers gets, it levels off to a certain point. They converge. This converges. Both the list and the summation of that list as you get bigger and bigger. Do you understand? But even though I'm looking at pretty much the same, I'm looking at the same quadrant, let's say this quadrant right here, do you see how they're both decreasing? Why is it that the blue one's summation, the series still converges? It's converging to what number, guys? 0. But why is it the summation, the addition of all those little things, it doesn't converge to a number, it still diverges. And it would go up to infinity. In other words, you will always be able to add something on the 1 over n, but then the e to the negative x, you won't always be able to add something. It will close it out pretty much and be so infinitely small. Who can tell me? That's as close as I can lead to you. Not because of quadrant 3, but nice assessment.
Scars gave this to you, right? So he's done. So we're all done with it. Okay, thank you.
Come on, guys. Alright, I'll show you. I'll tell you. Which one of these two things decays? They both do. Which one decays faster? E to the negative x decays faster than 1 over n. Can you tell me why this one is going to shrink faster? Because it's shrinking exponentially. If I exponentially shrink, I'm doing it a lot faster. Because this power is going to be like 2. 3, that's cubed. 4, that's to the 4th power. Whereas, what's the power here? It will always be 1. So it'll be like 1/2, 1/3, 1. You see what I'm saying with these numbers? So this one is still decaying, but it will not decay as fast as this one, where that series will always be adding something. That's very theoretical, but it's based off the premise that exponential growth is a lot bigger than power growth. So 1 over n, that's n to the negative 1. That means its power is just negative 1. Where here, this could be a negative 10, negative 1 billion, negative 1 trillion, so on and so forth. Alright. No worries. Let's keep going. Let's go to our last couple of pages. So our last couple of pages, we're talking about infinite series and sequences. So we've talked about it. As n approaches infinity, this is going to tell us whether it diverges or whether it converges. Okay? So here's my formula, and I want to see the sequence. In other words, I'm going to put in n is 1, n is 2, n is 3, so on and so forth, and let's list out the first several terms. We get 7.5, 7, 6.5, so on and so forth. Okay? If I were to keep going, would this converge to a number? Like, would it converge to 1? Would it converge to 0? Would it kind of taper off to a horizontal asymptote? Yes or no? No, this one would not. And a big reason why, guys, is because this function is not what? We just said it with the explanation of the last one. It's not geometric. It's linear in some sense. Okay? So it's not to a power. So there's no convergence. Okay? Now this is geometric. Okay? So the first term would be 8, and then 4, then 2, then 1, then 1/2, and so on and so forth. Would it converge? Yes, this will converge. What number will this converge to? 0. Okay? And then, this is geometric. Let's list out some terms. We have 8, 16, 32, 64. You see the pattern? Remember, we're approaching to infinity. Is this going to converge? No, it's out of control. It's growing out of control. Okay? So it's not going to converge. And then here we go. A plus n over n. Is this going to converge? And I'm talking about the terms, okay? So look at the terms. We have 9. We have 5. What else do we have? 3 2/3. We have 3. will these terms themselves converge, yes or no? Yes. What will they converge to? 1. So can you tell me why it's 1 and not 0?
Because if you have 0, then in denominator you will get a 0.
Ooh,
And that's
impressive. Okay, okay. Okay, I didn't think about that from before, but nice. There's another reason. Why is it 1? He's saying it can't be 0 because then it'd be undefined. Okay, but there's okay, tell me why it's 1 though. You just told me why it's not 0.
if you put 1 there, you're still going to get it 12. Plus if you do 1 there, you get it 9.
True, but my question to you is this. I wouldn't put 1 in here to get 9. I would put some huge number in here, like infinity, and it would give me 1. How does it give me 1? I'll still, right now with this question, offer that bonus as far as complete. How does it give me 1?
It divides by itself.
No, but good guess.
It doesn't give you 1, it gives you up to 1, right?
It gives you 1. Like it's so ridiculously close to 1, we say it's 1. You know what I mean? Like these numbers will get so close to 1 that we say it will taper off at 1. So, how do these numbers go to 1 and not 0? From this equation right here.
Yeah.
Say again?
The top's always going to be bigger because it's B.
Okay, so the top will always be bigger, and if the top is bigger, it could go off to infinity. It doesn't have to go to 1.
Yeah, exactly.
No worries. Okay, so I'll tell you. It's right here. If n is approaching infinity, you're basically trying to find, as you approach infinity, what will this thing equal? Okay? Guys, when you see this, you used to do it like this. So we're introing into calc right now. Okay? You used to know a horizontal asymptote with Bobo-Botten-Eads ratio. Remember that? And if you look at this, wait, is that what you said back there? Oh, okay. So look at this, Bobo-Botten-Eads ratio. Exponents are the same, so if they're the same, it's the ratio of the coefficients, which is going to be this 1 over this understood 1, and that's what would be the answer. Okay? So infinite limits as you're approaching infinity are horizontal asymptotes, and that's where you get those answers. All right, here we go. Last slide, guys. Last couple of slides. All right, so the 20th term, if I put 20 right here, would spit out a 0.0243. If I did the 30th term, just the amount for the 30th term would be 0.042, or 3 zeros. And if I kept going, I put 40, I put 50, I put 100, I put 1,000. Do you think, based off of what you see right now, do you think that would converge? Yeah. Now, don't get in a guessing game, because when I was where you're at, it's easy to get in a guessing game and have no idea what's going on, okay? It is converging. Why? Because it's geometric and r is less than 1. You with me? So what would it converge to? 0. Now imagine the series. So there's 20 numbers all lined up, and the 20th number is 0.0243. And there's other numbers here that when you add them all up together, that's this, you would get 161.95. If you added up the first 30, you would get 161.99. Does it look like their series is going to converge? Yeah, it's going to. What does it look like the series is going to converge to? 162. If it's geometric and this is going to converge, then this would converge. Okay? we're building some rules. Alright, so the next one you see, the 20th term is 61. The 100th term is 301. Do these look like they're converging to a number? No, they look like they're growing out of control. So these would diverge. Okay? And if I add these, you can see those aren't going to a number. It's not like leveling off at a number. So the series diverges. Okay? And then the terms. You have 4.05, 4.01. Guys, does this, if I kept going, look like it would converge? Yeah, it would converge to what? 4. And you could see that here. We just talked about this from before. The terms are going to converge. But the series, look at the series. Look what it's doing. It will not, it will diverge. Why again? Because this is not a what function? It's not geometric. Nor does it have an R value that is less than 1. Okay? Alright. To finish today's notes off, we have this last page right here. And all we're going to learn how to do is use this equation right here. So if we want to know what number does it converge, because some of you are like, how are people coming up with these numbers? You know what I mean? Especially the series. The series are a little bit difficult to see. Okay? The sequence, not so much, because it's just a list. But the series, they're a little bit difficult to see. Here's the equation that you can tell of where this infinite series is going to go to. This infinite sum. Okay? Here we go. Is it geometric? Yep. Is its common ratio less than 1?
Yes.
Yep. That means the sequence will converge, and it also means the series will converge. You with me? So here, let me say this again. R is less than 1. Does that guarantee that the sequence will converge, yes or no? The answer is yes. R less than 1. Does that guarantee that the series would converge, yes or no? No. If it's geometric and R is less than 1, then it would say yes. Okay? So if it's geometric and R is less than 1. Because the other one that we saw, the sequence was converging, but it wasn't geometric. It didn't even have an R. That's why it was still diverging as a series. Okay? So for the sequence to satisfy, just this, you're done. But for the series to satisfy with a geometric, you need it to be geometric and you need the R to be less than 1. Then you can say, yes, the series is converging. You with me? Okay, so I have both stipulations here. Both rules are there, and now I can use this right here. Okay? So it'll be the sum is equal to the first number over 1 minus R. And guys, you'll have to do this without a calculator, okay? Not bad. 1 minus 1/2 is 1/2. This would probably be easier to write like this. 16 divided by 1/2. Because of keep, change, flip. The answer that it will converge to is 32. You with me? Over here, the same thing. It is geometric because you see the power. R is less than 1, so this will work. And if you want to know what all these numbers would add up to eventually, where they would just stop, bless you, it would be 81 over 1 minus 2/3. Here we go. 1 minus 2/3 is 1/3. And 81 divided by 1/3 is the same as 81 times 3 over 1. So you have 243 is what it would converge to. The series would converge to. Questions? So if the series converges to this, what does the sequence converge to? What does the sequence converge to? 0. Okay? let's go to 14, our last piece right here. Couple things right here. First of all, sometimes you're not going to be given R. You'll just be given numbers. You have to find R. So if I did like 1.5 divided by 2, we know that's 3/2 divided by 2. Keep, change, flip. You can see that this is going to be 3/4. 3/4 could be the R value that you're going to plug in and solve for the rest. So it would be the first term, which is 2 over 1 minus 3/4. You'd get 1/4. So that you would see that it would converge to 8. Okay? So last thing right here. The geometric series has R 1.2, which is bigger than 1, so it will not converge. The formula does not apply because the sum diverges. Okay? And it can't be found. The real-world application of this is actually really, really cool, but you don't really truly experience it until Calc PC, which is Calc 2. Okay? But there it is. One more day.